Okay, so we're going to look at a few more examples of complex algebra problems. But one, I realized as I'm looking back at my notes, I forgot to make that connection of the polar graph. So if I were to have connected our two solutions from the last example here, remember we had one in quadrant 2 and one in quadrant 4. So if I would have connected these two, notice I would have gotten the polar lemniscate. So now that I've shown you that, I can sleep tonight and making that connection of why we see polar graphing and why we do that first. Because again, it's a nice visual representation of where these complex solutions are going to exist. Okay, so let's go ahead and solve examples 4 next, and we can do 5. Now, I'm already noticing that I don't have real coefficients, so I'm not going to worry about the complex conjugate pairs. Remember, that only happens when you have real coefficients. But I can express this number in its polar form, so -4 plus 4 root 3, so -4, so go over 4 and then up 4 root 3 in the I direction. So that's going to give me a hypotenuse, or a distance away from the pole or the origin, of 8. And that's a 60-degree reference angle here. So outside, that's 120. So now I have x cubed is equal to 8 cis 120 degrees. And remember this 8, that magnitude, is always going to be positive. And then we have our argument here, 120 degrees. So now I'm going to take the 1/3 power, or the cube root, of both sides. And the cube root, at least for the 8, becomes a 2. And remember, when I do the quote-unquote cube root of cis 120, it becomes cis 40, because 1/3 of 120 is 40. Now, there are 3 solutions I'm looking for, and because the 3 solutions have to be equally distributed, I'm going to take 360 degrees and divide by 3, so I get 120. Now, some of you might be thinking, ooh, this kind of looks like plus 120k, where k is an integer, and that's exactly right. You're going to continue to add 120 until you've gotten all your particular solutions. So if I add 120 degrees to get my second one, I could say 2 cis 160 degrees. And if I add 120 degrees more, let's pick this guy. That's a nice color. So I had, try that one more time. Pick that color. There it is. So if I add 120 degrees more, I get 2 cis 280 degrees. Now, don't panic. We didn't do anything wrong, but we did get 3 angles that are not 30, 60, 90 or 45, 45, 90 triangles, and that's okay. We would just leave them as in their polar representations. Without a calculator, I don't know what the cosine and sine of 40 is. So I could just leave them just like this, like these 3 solutions right here would be the answer. And certainly you can look at, I could graph, 40 degrees and go out 2, and then I can graph 160 degrees and go out 2, and I can go out 280 degrees and go out 2. And so I do still have the symmetry, and I could still come up with a polar equation of a 3-petaled rose that would have those particular solutions, but maybe it just rotated, right? Maybe it's rotated 10 degrees from nice values. Think about it. 10 degrees from 40 is 30. 10 degrees from 160 is 150. 10 degrees from 280 is 270. So that, again, is why it's important to talk about those rotations. Okay, let's solve the next one. Again, kind of looks intimidating, but we'll have a little faith here that this is going to work out nice. Again, not real coefficients, so I'm not expecting complex conjugates, but I do want to isolate our x cubed. So let's go ahead and bring that over. Remember, because it's x cubed, like the last one, we're expecting 3 solutions. And so if I say, let's go maybe this color. So I'm going to say, x cubed equals -125 root 2 over 2 plus 125 root 2 over 2i. So that way I have the in the a plus bi form. If we graph this over and up, it's a 45, 45, 90 triangle. And again, these aren't maybe the nicest initially till you realize, wait a minute, x root 2. So my hypotenuse is exactly 125, because if I do root 2 times root 2 is 2, and that 2 cancels. So this hypotenuse is 125. And notice our angle is 135 degrees. So this is the same thing as saying 125 cis 135 degrees. And again, our magnitude will always be positive because it's a distance, and then 135 degrees right here. So now if I'm going to cube root both sides, or do the 1/3 power, so now I'm going to get the cube root of 125, which is 5, which is really nice, cis, and the cube root of cis 135, remember we're just doing 1/3 or dividing it by 3. So we get 45 degrees. Now that's a really nice number. So now I can say, okay, well, there are 3 solutions. Again, 360 divided by 3 is 120 degrees. So they're each 120 degrees apart. So if I add 120 to that one, I would get 5 cis, and 120 to that is 165 degrees. Again, no panic. There's no guarantee that they're always going to be nice angles. And then if I go one more, add another 120 degrees apart, so then that becomes 5 cis, would that be 285 degrees? Those are my 3 solutions. Now, the principal one would be the one that came first. So that would be, I'll go yellow, I guess. That'll be this one. So here's our principal one. And notice our principal one actually has a nice angle. I could express this in a plus bi form. This is our second solution, and then this is our third solution. And that order of first, second, third solution, the order that they appear is just based on the magnitudes of the angles, not it's just the magnitude of the arguments or the size of the arguments. And that's actually going to come into play in a couple of examples coming up. Look at that, number 6. It's talking about a certain set of solutions, the second and the seventh. So if I were to graph these in order, I want to pay attention to just those 2 particular solutions. And you have to read this through maybe twice to say, wait a minute, complex 10th roots, but I want the second and the seventh. So 10th roots, so that means there are going to be 10 solutions to this problem. I'm interested in just the second and seventh of all of these solutions. And so it's looking for the 10th roots of this number here. So like if I just, if I take that, okay, I want the 10th root. So like instead of a square root, it's the 10th root of negative 512 minus 512 root 3i. That's sort of one of that way we can interpret this question. But another way, perhaps a better way, is to think about there's some number that when I raise it to the 10th power, it's going to equal negative 512 minus 512 root 3i. So from this perspective, I like it better because now I know I'm going to get 10 solutions, where in this case, what I first wrote, that is assuming I just want the first one. So let's think about it in this context and think, okay, some number to the 10th power is equal to this. Now let's write that into its polar representation. So if I go over negative 512, down 512 root 3, so that's down to here. So that's over 512, and then down 512 root 3. Well, maybe from your game of, if you ever played 2048, or your doubles, 512, like if it's x root 3, if I double 512, that's 1024, which is 2 to the 10th power. So this was picked nicely because 2 to the 10th power, when I do the 10th root of 2 to the 10th power, is going to be a nice number. And since this is the 60-degree angle reference angle, this becomes 240. So now polar representation, x to the 10th power is equal to 1024, which is 2 to the 10th power, 1024 cis 240 degrees. And when I do the 10th root of both sides, the 10th root of 1024 is nicely 2, and then the cis 240 becomes cis 24 because that's 1/10 of it. I did 360, divide by, so now I'm going to do 360 divide by 10. So 360 divide by 10. So that means each of the solutions are 36 degrees apart. So the first one, the principal one, has an angle of 24. The second one, and remember that's one I'm interested in, I'm going to add 36 degrees. So now the second solution is 2 cis 60. And that's nice. Adding 36 to that 24, that gives me a very nice argument, and I will put that into A plus BI form. So then I want the seventh one, so I'm going to add 36. There's the third solution, which would have an A, so that's 2 cis. If I add 36, that's 96. Add 36 more. And I don't necessarily have to write all these out, but I will just to illustrate this. So that's 132. If I add 36 more, now I'm at 168. And notice the 2 cis, like the 2 is still the same distance from, the origin. So we have the first solution, the second, third, fourth, fifth. So if I add 36 more, 36 more to 168, that would be 204, I believe. So 2 cis 204. And if I had 36 one more time to get my seventh solution, 2 cis 240. So I actually have two very nice arguments, and that's why this was picked on purpose. 2 cis 60 degrees is one of my solutions. 2 cis 240 is my seventh solution when graphed in order. So let's go ahead and put those into A plus BI form. So you draw a 60 degree reference angle. Let's go orange. So you have your not highlight though, pen. You have your 60 degree reference angle. So there's out 60, a radius of 2, so it's over 1 up root 3. So the second solution is 1 plus root 3i. And then if I go 240 degrees, which actually is exactly opposite, I'm going to go -1 and then down root 3. So that would be -1 minus root 3i. And again, kind of emphasizing two things. One, order matters. So this is the second solution. So I might want to indicate that, pick that color there. So here's our second solution, and here's our seventh solution. And then two, these are not complex conjugates. And that's maybe what the second question is saying, how are these related, or how are they not related? And it's okay that they're not complex conjugates because we didn't have real coefficients to start with. Okay, let's do example 7 and 8 on this video, just to kind of, tie up maybe these two examples. Notice example 7. So example 7, if I can try to get them. Oh, there's 10. That's nice. 9. That's nice. 8 and 7. Notice the square root's already given. So this particular question is looking for the principal root. But I'm still going to set it up as if saying, okay, there's some number squared that's equal to that number underneath the square root symbol. And so I know that what I just wrote has two solutions. I'm just going to want the first one, the one that comes in order as I start solving this. And again, thinking about putting this, representing this in its polar form. So I'm going to the left, 200, up 200 root 3. So over 200, up 200 root 3. That's going to give me my polar representation. So this distance here is actually 400. So if I go over 200 in that direction and up 200 root 3 in this direction, that's a 60 degree reference angle right there. So that's 120 degrees on the outside. So this is equivalent to 400 cis 120 degrees. Okay, so then I'm going to do the square root, or the 1/2 power, and paying attention to just the first solution. So the square root of 400 is 20 cis And then the square root of, or the 1/2 of 120 is 60 degrees. Now, if I wanted both, remember, I'd have to add 180. If it asked for, oh, what's the next solution? I'd say, okay, I would add 180 to that, and I get a second solution of 20 cis 240 degrees. There's the second solution, or the secondary solution, but I just want the principal one, which comes first. I just want the 20 cis 60. So whether you see it in your head or actually draw out a 60-degree reference angle, hypotenuse of 20, that's over 10 and up 10 root 3. So the principal answer would be 10 plus 10 root 3I. So there's the principal root of the number that we were given. Okay, so we got one more example I'll do in this video. I want to do an expansion one. So kind of going back to maybe an earlier example. Now, again, not the nicest of numbers here, at least on the initial glance here. But let's have some faith in that this will come out nicely. So if I go over and up the same amount, no matter what that number is, it's going to be a 45, 45, 90 reference angle. So if I go over and up the same amount, I'm sitting at a 45 reference angle in quadrant 2, which is 135 degrees as the actual angle, or the actual argument. And remember, it's x root 2. So the hypotenuse is going to be root 2 as big as this, these each legs. So if this is over root 3 over root 2, and this is up root 3 over root 2, then this hypotenuse itself is going to have a distance of root 3. So the polar form of this is the square root of 3 cis 135 degrees. That's what I'm going to take to the 8th power. So then I can say, okay, well, root 3 to the 8th power is the same thing as saying 3 to the 4th, because every pair of roots become a normal 3. And then cis, and then I'm going to take 8 times 135 degrees. So 3 to the 4th is 81, same thing as 9 squared, cis, and 8 times 135 is 40, carry my 4, that's 24, 28, carry my 2, so it is cis 1080 degrees. Now, clearly bigger than a 360, so if I go around once, that's 360. If I go around twice, that's 720. Here's 900. So if I go 180 more, that's 1080. So this is the same thing as saying 81 cis 0 degrees. Well, that's super nice, because if I go an angle of 0 degrees, I just go 0 degrees and have a radius of 81. In other words, the answer is just 81. There's no imaginary component to this example. Okay, so again, maybe pause the video before you play the second one, or the third one, I should say. Maybe try the other examples and see what you can do. And then, if you have any questions, follow along, because I'll work through those examples and then let me know what questions you have.